Hey kids, this is lesson for day 105, angle measures. Today you're going to be able to determine the measurements of angles. So what I'd like you to do is have your notes out. We're going to write down what's highlighted here, the title and the objective, please. Let's have the teacher pause the video. Alright, so today we're going to talk about angles. We see angles all around us. We have two sides of things, and we could classify them different ways. The one that you most commonly see is like a right angle. It's 90 degrees. Buildings are made with right angles because they're the most structurally strong, right? If you have a building with a wall that's hanging sideways like that, then your house probably will fall, right? So, and then we have different other types of angles. So think about these. You could write them down as I talk about them. We have the acute angle. Remember, an acute angle is an angle that's going to be more than 0 degrees, right? But it's going to be less than 90. And then we have the right angle, which is an angle that is exactly 90. And check this out. You got this little box in the corner right here. This little box, if you have an angle and it has a little box in the corner, we could assume that the picture is saying 90 degrees exactly. Next we have the obtuse angle we've talked about before, or angles that are going to be greater than 90 but less than 180. So, and then of course we have a straight angle, and you're like, what? That looks like a line. Well, it does look like a line, but if we think about this angle has a vertex at A. If we measure starting from here to this way, it goes 180 degrees, right? Where this one went more than 90 but less than 180. This one went exactly 90, and this one went less than 90. So technically our straight angle is an angle. So these are the angles. You should know these already, but just a quick review. So today what we're going to do is we're going to figure out what the measure angles are. So let's do a little quick little activity here. Let's have the teacher pause the video as groups. We'll discuss how many angles do you see. Name the angles, and I'll help you with one of them. Let's say this was my angle here. What's this angle called? This angle is called BEC. So that's my first angle, so I'm going to call that angle BEC. Alright, let's have the teacher pause the video. Alright, here we go. Here are some more angles. So notice that BEC has an angle in the middle. This is called 3. We could call angle BEC angle 3. It's the same angle. Okay, we also have AEB. I'm sorry, angle AEB, which is angle 2. Right? We also have angle CED. Which is angle 4. And then we have the straight angle. If you think about this, we have angle AED, right? That's our straight angle. And then we have our next angle. We could combine angles, we could see that this is an angle here. We have AEC, right? Angle AEC. We also have another angle right here. We have angle BED. And I don't think I could see any other angles. Alright, so those are all the angles. So there's a way you could look at those. Maybe I missed one. I don't think I did, but it's kind of fun to see a diagram and name all the angles. Alright, so today we're going to learn how to measure. So you're going to get this thing called a protractor. It looks like this, right? It's here on the bottom left right here. I'll show you what that is. in a moment how to use that, okay? So the teacher will pass one out to you at the end of the lesson to each of you. So here we go. So number 1, the question or the directions on all 4 of these are use a protractor to find the measure or construct each angle. Okay, so you don't really need to write the steps here. You should write them down later, but I don't want to use class time for this because I want you to practice this versus just writing it down. So when we use a protractor, or when we measure angles, we can use a protractor to measure them, to be precise. The protractor, like I said, looks like this right here. So anyways, number 1, we want to measure this angle right here, angle PQR. Okay, so how do I do that? So on your paper, I always like spinning my paper around so I got an edge that's down. So check out number 1. I'm going to spin number 1 around. Alright, look what's going to happen. Okay, dang, look, I spun PQR, right? So the bottom now is at the bottom, which is nice for me because I could focus on the bottom. I brought my protractor out here also, and I'm going to slide the protractor up. The protractor has 2 parts. There's this line on the bottom, and then we have all of the various angles that are here. And basically, we have a point here we want to connect my vertex to, and then from there I can measure any angle I want, okay? From left to right, or right to left, alright? So I got my angle, or my paper spun around, I got my protractor out, and I'm going to just slide this thing up, okay? So watch carefully. I'm sliding it up, and I'm putting it at the vertex here, okay? So notice that it's at the vertex here, and notice that one side is perfectly on this bottom line. Alright, so now that it's perfect, I'm going to measure my angle. So my original angle, I could predict that it was acute, right? It's less than 90 degrees, so I need to have an answer that's less than 90, okay? I don't want to pick a bigger answer. Notice on my protractor that I have angles that could be greater than 90, so on each side. Alright, so now that I've lined up my protractor, I'm going to look up and go up here and see where it ends. I'm noticing I got a couple numbers here. It says 60 and 120. So I don't want to pick 120 because I know this angle is supposed to be acute. So I'm looking here at where it ends, and it ends at 58 degrees. Okay, so the measure to angle PQR is equal to 58 degrees. Okay? Super easy, right? Number 2. Let's look at number 2, everyone. Number 2, we're going to measure it. What do you predict this angle is going to be? An acute, an obtuse, a right angle, or a straight angle? I think it's going to be obtuse, right? Definitely looks bigger than 90, less than 180. Not a straight angle. Okay, same idea. On this one, I don't need to really spin my paper around because like the bottom is real nice and easy to see, right? I got a vertex here. I want to line up my protractor to, and this angle is called angle DEF. Okay, ready? Pulling out my protractor, I'm going to put it right onto the vertex. Okay? Put it right there. Perfect. Next thing I'm going to do is make sure that my one side of my angle is on this big line on the bottom. It is. It's covering it perfectly. My vertex here is perfect here. So now I could focus on the angle. So I know the angle goes all the way past 90, so I want a bigger answer than 90. And look at these. We have smaller answers than 90 here. We don't want to use these smaller answers. Okay? So as I look, I'm looking over here, and I see that the angle is almost at 170. And the line doesn't quite make it, so I'm going to keep going here, and I'm going to look and try to carefully see what's going to go to. And it looks like it's probably at about 167. So the measure to angle DEF is 167 degrees, okay? And we write 167 with this little circle at the top right. That's degrees. That's the measurement of the angle. Okay? Cool. So that's numbers 1 and 2. Number 3, it says 19 degrees. So what do you think it's going to ask you to do? You're going to draw this angle. Okay. So the first thing to do when you draw an angle is start with one of the sides of the angle. So just put a side of the angle down. Okay. I drew it right here. Okay. It doesn't matter how long it is. You probably want it to be a little longer than your protractor radius, but this is okay. And then I'm going to put my protractor, put that little point here at the tip of, or the end point of my ray here. Then I'm going to bring out my protractor. Okay, notice that I put the point here carefully and it's lined up with my ray. Okay, it's asking for a degree angle measure that's 19, so I'm going to go up only 19 degrees, and if you look here, 19 is going to be right here. Okay, so now I'm going to make a little mark here at the edge of 19. Okay, the next thing I'm going to do is I'm going to draw a line from my vertex here. I'm going to have to take off my protractor and draw a line from here to here. Okay, so when I do that, I got a line here, and then I take off my protractor and I'm done. I could put a little end point there. Alright, I'll do that again. This one, angle 100. Okay, first thing I want to do is start with my edge of my angle, or a side of my angle. This is also called a ray, right? Then we're going to take our protractor and point it to the end point of the ray, and then I'm going to draw my line. I know it's 100 degrees, and then I'm all done. Okay? Anyway, super simple. So that's how we measure it. Now a couple more things. Notice that on the protractor here that you could add angles. Like let's say I put another angle, or let's say I put another line here at like 20, and then we had this line here. Well, check this out. From here to here it's 20 degrees, and from here to here, remember we went to 100, so 20 plus what is 100? It's 80, right? So this angle measure here is 80, and this one is 20. Okay, so I want you to know that we can add angles together that are next to each other to make a larger angle. So here is a postulate you should know. It's called the angle addition postulate. And it says if S is in the interior of angle PQR, which is, there's S, and it's in the interior of PQR, there's S, that means that we know that the measure of angle PQR is going to be equal to PQS. We're going to add this one plus SQR, and we're going to get PQR. Okay? So that is the angle addition postulate. And now that's the end of the lesson. So the teacher's going to pass out a worksheet to each of you, and you're going to complete that for the rest of the period. You have your iPads out at the end. You could work on AM or AM 2.0s if you're not done. And of course there's that worksheet with the circles. You can work on that also in class. So we got plenty of work to stay busy. And that's it for today. Thank you so much, kids. Bye-bye.